Okay, so let's have a look at this question here. So this is a problem-solving question. It fits a lot of the characteristics of a problem-solving question. It's got quite a lot of words in it. There's a lot of information. It's 5 marks, we can see. So this is a really important thing to note. This is going to be a number of steps, thinking every mark is allocated for something in particular. So we need to maybe thinking about that as we're working through it. What is it that's going to get me each of those 5 marks? Okay, so let's read the question. So this rectangular frame, so rectangular means there's a rectangle involved, okay? It's made from 5 straight pieces of metal. Okay, so I can see those, can't I? One there, one there, one there, one there, and then one cutting across the middle. So 5 straight pieces of metal. Okay, so the weight of each piece of metal is 1.5 kilograms per meter. So that means every meter of this is going to be 1.5 kilograms. And what we're being asked to find is the total weight of the metal. Okay, so let's have a little think about this now. So if I work backwards from there, and I just think, okay, so I'm trying to find the total weight of the metal, trying to find the total weight of the metal, and I know it's 1.5 kilograms for every meter. What I actually need to find is the total length of the metal. So that plus that plus that plus that and plus that. Okay, so let's think about that. So this length here, do I know that? Well, yes, I do. And actually, that is going to be the same as that because it is rectangular. So we know, because it's rectangular, we're using the information that we're given here, that we know that that side is equal to that side, and that side is equal to that side. So that must be 12 centimetres. Okay, so now all we're missing is this. So let's call it X. Now, how are we going to find that? Now, we know this is rectangular, and actually it's told us something here, hasn't it? Maybe I should have highlighted that. This is a right angle. So this here is a triangle. And I've got 2 sides. In fact, it's a right angle triangle. So this is a Pythagoras question. And this is really the key to this question. So I know that x squared is 12 squared plus 5 squared. And if I stick 12 squared plus 5 squared into my calculator, I get 169. So x is equal to the square root of 169, which equals 13 centimetres. And if it helps, we can write 13 centimetres on the sketch. Right, so lovely, we're a long way to getting there now. So the total metal, remember to think about making it nice and clear for the examiner. Sorry if this is scruffy, it's very difficult to write on this. So the total length of metal is 5 plus 5 plus 12 plus 12 plus 13. So that is equal to, just quickly do it on my calculator, 5 plus 5 plus 12 plus 12 plus 13. I'm not going to try and do it in my head because I'm going to make a mistake. So that is equal to 47 centimetres. Okay, now, so that's the total length of the metal, and I would have thought probably what we're going to be getting here is 1 mark for using Pythagoras, 1 mark for getting the length of the diagonal, 1 mark for adding them up, possibly even a mark for recognising that's 5. And then finally, what we need to do is to find the total weight of the metal. So we know it is 1.5 kilograms for every metre. So we need to multiply the length by 1.5. So if it's 1.5 for every metre, and I've got 47 metres, then the answer is going to be 47 multiplied by 1.5. So I do that on my calculator, and I get 70.5 kilograms. Now, I think really the key to this was reading the information and getting the plan, spotting that it was a Pythagoras question. And once you were through there, it actually became something reasonably straightforward. None of the maths was that difficult. It was the deciding what to do that was key. And there's 5 marks in the bag towards your GCSE. Okay.